Dear students, now we'll move to the second session of this particular solid state. In the previous session, we have defined what the solid is and how the solids has been classified, and also we have mentioned what are the various characteristics related to the solids. So here, based on the regular arrangement or the irregular arrangement of the particles, we can have the two types of solids called as which and which? The crystalline solids and then the amorphous solids. That is, a solid in which, solid means first it is having a close and compact arrangement of its particles with higher rigidity. If all those has been in a particular order, then that particular solid is considered to be the crystalline solid, whereas the same solid where the particles are not so regular, means irregular arrangement of particles in the given solid refers to the which one? Amorphous. That is why we can have the definite shape related to the crystalline solid, but no definite shape with respect to which one? The amorphous. And then the important characteristic property with respect to these two are, crystalline solids are anisotropic, whereas the amorphous are found to be the isotropic. Means the various physical properties, preferably the electrical properties and then the mechanical strength, for a given solid, if it has to be measured in various directions, and if the values are found to be the same in all the possible directions what we have measured, if it is found to be the same, means it is called as isotropic, and that is a characteristic feature with respect to amorphous. Whereas in case of the crystalline solids, they are found to be anisotropic because the properties, that is what we have said about some of the physical properties in the form of electrical conductivity or a refractive index or mechanical strength. If I measure all those properties in all the possible directions, we are getting the different values of that. On that basis, it is found to be the anisotropic. That is why the crystalline solids will have the anisotropic nature, whereas the amorphous solids will have the what nature? Isotropic nature. Okay, so that is about some of the differences also we have mentioned between those crystalline and then the amorphous. Then, based on the nature of the particles and the type of interactions between the individual particles, the solids has been broadly classified under four different types called as molecular crystals, ionic crystals, then we are having the metallic crystals, and followed by the another one is that is called as covalent crystals. So next we are having the classification of crystalline solids. Crystalline solids, or sometimes they can also be simply called as the crystals also. We can use the same word. That is, either it may be the crystalline solids or simply we can mention that in the form of which one? The crystals. So here this is based on the nature of particles present. Nature of which one? Particles. And the type of interactions between the individual particles. This has been classified under four types of crystals are existing. We are expecting the how much? Four different types of crystals are simple. Another word is the crystalline solids. So the first one is molecular crystals are solids. The second one is the ionic crystals, or sometimes they can also be called as electrovalent crystals. And the third one is considered to be the third one is the covalent crystals are network solids also they are calling. Crystals are to be the solids. And finally, we were having the metallic crystals here. Means, here this classification is strictly based on the type of the particles, or what are the nature of the particles that has been present, and what type of interactions that has been existing between those different particles can lead to the classification of the crystalline solids under four different categories called as molecular crystals, ionic, or it is also called as electrovalent crystals, then covalent or network solids, and finally the metallic crystals. So for all of this, the common definition is what? These are the crystals, are the crystalline solids in which the particles are of, these are the CS, what is that CS here? The crystalline solids, wherein the particles are of the neutral molecules, preferably held by either the weak van der Waals forces or the strong hydrogen bonding. The weakest force that has been existing between the particles is usually the van der Waals. Those van der Waals are of again three types. What are those? Dipole-dipole interaction, induced dipole interactions, and then the induced dipole and then the induced dipole interactions. So that we have already discussed in the first year when we are discussing the states of matter, preferably for the gaseous nature. Okay. So here the particles are strictly what in nature? Molecules, which are held by either the van der Waals force or sometimes it may be the strong hydrogen bonding also. If that's be the case, it is called as what crystals? Molecular crystals. So here, this is also the same CS. What is that CS means? It is a crystalline solids, or simply it is also called as crystals, wherein the particles are of oppositely charged ions held together by which one? An electrovalent bond, or simply it is called by another one that is called as ionic bond. Means here what the particles are? The ions. What type of ions they are? Strictly they must be the what charges? Oppositely charged. And what is the net interactive force existing between the oppositely charged ions? It is indirectly the what forces? Electrovalent forces, or it is also called as which bonding here? The ionic bond. Okay. Then we are having the which one? The covalent, or it is also called as crystalline, network solids. These are also the CS. What are CS means? They are the crystalline solids, wherein the particles are of either the, we can have the two chances. Sometimes it may be the neutral atoms, or sometimes it may be the neutral molecules also. There is an exception case here. Either the neutral atoms, or it may be the which one? The molecules also, held together by the strong which bonds? The covalent bonds we are calling. Again, what are the particles here? Either it may be an atom, or sometimes it may be the molecules. Here also we are having the molecules, but they are held by the weak which bond? Van der Waals bond. That is why they are referring only for the which one? Molecular crystals. But there also we are having the molecules, or sometimes it may be the neutral atoms also. But the interactive force between them is going to be the strong covalent in nature. If that be the case, it is called as what bond? Crystals. Covalent crystals, or sometimes it may be also called as a network solids. Why it is called as network solid? Means because once the covalent bond formed it is having a catenative property. So that catenation may extend that in a three-dimensional region, and that three-dimensional nature is considered to be the what? Network. That is why the covalent crystals are also sometimes referred to as the which one? The network solids. So here, these are also the crystalline solids in which the particles are of metal cations of the metal cations of the metal, and they can be simply called by another name that is called as kernels. We are using the word as which one? Kernels. Held together by an electron cloud in the metallic crystal lattice. It is called as lattice, means it is a three-dimensional arrangement. Metallic crystal lattice. Through the metallic bonding means it is called as what crystals? metallic crystals. Means here the particles are what? Kernels. It's a new word. What that kernel is? It is actually the metal cations of the metal. Okay, that we'll take when I'm discussing about the examples related to that. And the bond between them is found to be the what? Metallic in nature. If that be the case, it is called as what? Crystals? Metallic crystals. Means how the crystals or the crystalline solids has been classified? Based on what type of particles are present between them. Means the particles may be either in the form of an atom or a molecule, or sometimes it may be the ions also. And then the type of interactive force existing between those particles, means whether it is a covalent bond or an ionic bond or a metallic bond or a weak van der Waals bond or a strong which bond? Hydrogen bond. Means type of particles and then the type of interactions between those particles, we can classify that particular crystalline solids under 4 different categories in the form of either the molecular crystals, ionic crystals, electro-covalent crystals, and then the metallic. So let us have the examples related to this first. Okay, molecular crystals means they are the crystalline solids wherein the particles are of what? Strictly the neutral molecules. Means the particles are what here? Molecules. And those are held by which one? The weak van der Waals forces, or sometimes it may be the strong hydrogen bonding also. Again, molecular crystals are of 3 types. Which one? The molecular crystals are further classified under 3 different categories. The first one is non-polar MCs, polar MCs, and then we are having the third one, hydrogen bonded MCs. All these are which one? Which one? They are the molecular crystals. What are molecular crystals are? They are the crystalline solids, are the crystals in which the particles are of what molecules? The neutral molecules. And those neutral molecules are held together either by the which bond? The weak van der Waals bond sometimes, or it may be the strong hydrogen bond also. And based on the nature of or the type of the van der Waals force existing in that, the molecular crystals are further classified under 3 different categories in the form of non-polar molecular crystals, polar molecular crystals, and then the hydrogen bonded molecular crystals. So here, what the non-polar this one are? These are the what crystals again? The molecular crystals, in which the particles are of what molecules? Neutral molecules. But here, those molecules are non-polar molecules. Here the molecules are what? Non-polar. Means the difference in electronegativity is almost 0 or it is exactly 0. Which are held together by London forces, or it is also called as the dispersion forces. We are indirectly calling that as the induced dipole interactions also. Because that is the last other weakest force existing with respect to the van der Waals, that is called as a induced dipole, and that is also called as the non-London forces, or it is also sometimes referred as the dispersion. So for example, solid iodine. What's that? Solid iodine. Let us have the example related to this. This is iodine. Okay. So as its atomicity is 2, iodine molecular atomicity is 2, means number of atoms which can form the iodine molecule is just only 2. Here, the electronegativity of the 2 iodine atoms are found to be similar, means if the difference in electronegativity is found to be the what? 0. Means this is found to be the delta naught and this is found to be the delta naught. What is the meaning of that? It is non-polar. What polar here? It is non-polar. Suppose if another solid iodine molecule has interacted here. This is having delta naught, this is also having delta naught here. Again it is what? Non-polar and then non-polar. But as if you know that, as there is a close and then the compact interaction between the particles with respect to the any solids. Suppose if 2 solid iodine molecules come together, what happens? When this gets entered into this one, or when this approaches this gets a partial negative, for example, to get a partial positive with respect to this. So if this is partial negative, this gets a partial positive here. If this gets a partial positive, means this gets a partial negative. Means it is not a polar here. It is on induction. When the induction takes place, when the first non-polar molecule approaches the second non-polar molecule, or the second non-polar molecule approaches the first, what happens? Both the forces gets disturbed. And that dispersion or disturbance is nothing but the dispersion, or it is also called as the London force. And that London force is due to it creates a dipole, but it is not exact or the original. It is called as induced dipole and then the induced dipole. That is why we are getting the bond between them is going to be the what? It is called as a London force, or it is also called as dispersion force. And that solid iodine now is an example for a non-polar molecular crystals. Why it is called as non-polar molecular crystals? Because the particles are only the neutral molecules which are held together by weak van der Waals bond. So here, which is the weak van der Waals bond? Here it is the London forces, or it is also called as the dispersion forces, or indirectly we are extending that in the form of induced dipole interactions between the two molecules of solid iodine. That is why it is called as what crystals? Non-polar molecular crystals. Okay. So now let's have the polar molecules. The same thing. These are also the molecular crystals in which the particles are of the polar molecules. Which molecules they are? They are the polar molecules, and they are held by dipole interactions. What type of interactions they are? Having the dipole interactions. Dipole interaction. Let us take an example with respect to the solid hydrochloric acid, or not it is hydrochloric acid, it is a solid hydrogen chloride. Why it is not hydrochloric acid? Means HCl standard state is actually the gas. Only if it is when dissolved in water it splits into H plus and then the Cl minus, that is why HCl in aqueous is considered to be the hydrochloric acid, but it is just only the hydrogen chloride. Okay. So here HCl, for example, as if we already know that, what is that? The chlorine is the more electronegative compared to that of which one? The hydrogen. Therefore, this gets a partial negative and this gets a partial positive. That is why HCl is an example for a which molecule? Polar molecule. As if I am not choosing the HCl in the form of gas, here HCl in the form of solid. That is a solid HCl I am taking the example. Means there is an approaching of the another HCl molecule very close to this. And again, this molecule is also an example for a what? Polar molecule. What happens when these two polar molecule gets attracted here? Now, there exists one interaction, and that type of interaction is called as what? Dipole interactions. Already the molecule is what? Polar. If the two polar molecules and the solid particle arrangement to Fe as it is very close to each other, there exists a force called as the dipole interaction between the two polar molecules with respect to the given crystals is called as polar molecular crystals. Therefore, what polar molecular crystals are? They are the molecular crystals, are the crystalline solids in which the particles are the neutral polar molecules which are held together by which one? The dipole interactions. The best example related to that one is solid hydrogen chloride, or you can use solid sulfur dioxide also. Okay. So let's have the last one. What's that? The hydrogen bonded molecule, hydrogen bonded which one? Molecular crystals. These are also the which one? The molecular crystals in which the particles are of the polar molecules. Again, particles are the same polar molecules, but they are held by what bonding? Hydrogen bonding. If the polar molecules, if they are held by dipole interaction, it is called as polar molecular crystals. If the same polar molecules which are held together by a new type of force, that is called as hydrogen bond between them, then it is called as hydrogen bonded molecular crystals. First, what is hydrogen bond? It is an electrostatic force existing between the hydrogen with the more electronegative atom. And the combining capacity with respect to the hydrogen is found to be the more electronegative, but it is having the smaller size. The hydrogen can have the hydrogen bonding with respect to only 3 elements of higher electronegativity with smaller atomic size. Maybe the first is chance is given for fluorine, the second one is for oxygen, and finally we can have only for the nitrogen. Means fluorine, oxygen and nitrogen, these elements can have the hydrogen bonding. Even though chlorine is going to be more electronegative than oxygen, but chlorine doesn't form a which bonding? Hydrogen bonding. Why? Because of its what charge? What size? Larger atomic size. The condition is higher electronegative with a smaller atomic size. Only 3 examples related to the atoms, that is only the fluorine, oxygen and then the nitrogen. Okay. The best example that we have considered with respect to this hydrogen bonded is ice. Ice, we know that it is a solid state of that. Okay. Let's have the diagram related to this. I just rubbed this. Okay. The third one is what? Hydrogen bonded which one? Molecular crystals. HOH. What is this? Water. What water is? A polar molecule. So as if we know that oxygen is partial negative, therefore hydrogen is partial positive. Again we will take another molecule of which one? Water. HOH. 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 Delta minus, delta plus, delta plus. Delta plus, delta plus and delta minus. Delta plus, delta plus and delta minus. I have chosen the 4 H2O molecules. What H2O molecule is the best example for a universally accepted polar solid. Means the molecule is what? Polar in nature. Because oxygen is more electronegative and hydrogen is more hydrogen is going to be the electropositive. Now, as it is an ice, means the H2 molecules will come close to each other and they form which one? Hydrogen bond. Here it forms hydrogen bond. Here it forms hydrogen bond. Here it forms hydrogen bond. So here oxygen with hydrogen or hydrogen with more electronegative oxygen through the intermolecular hydrogen bonding. It is taking place between the 2 different molecules of H2O. That is why it is called as intermolecular hydrogen bonding. Okay. So that makes the vacant space inside that, and this is a real structure with respect to which one? The ice. If I extend this, it will go on like this. What this is? A structure with respect to ice. So here the particles are again what in nature? Polar in nature, but the bonds between them is going to be the what? Strong hydrogen bonded. That is why they are called as hydrogen bonded molecular crystals. Means what molecular crystals are? They are the crystalline solids are between the crystals in which the particles are of what molecules only? The neutral molecules, and those are held either by the 2 chances. What are those? Either the weak van der Waals interaction or sometimes it may be the strong hydrogen bonded. And based on the nature of the van der Waals interaction existing between the molecules, we can have the 3 types of molecular crystals called as non-polar molecular crystals, polar molecular crystals, and finally the hydrogen bonded molecular crystals. What is that non-polar molecular crystals here? They are the molecular crystals in which the particles are of the neutral non-polar molecules. They are the neutral non-polar molecules wherein those molecules are held together by the weakest force, that is called as the London forces, or it may be the dispersion forces, or extensively we are calling that as induced dipole interaction. If that be the case, it is called as non-polar molecular crystals. The example that we have chosen is solid iodine, or I can choose solid hydrogen also, or I can choose the solid chlorine also, because they are the best examples related to the which one? Non-polar. Okay. Then the second one is going to be the polar molecular crystals. What polar molecular crystals are? Again they are the crystalline solids, are the crystals in which the particles are of same the neutral molecules, but those neutral molecules are strictly what in nature? Polar in nature. Means the molecules are polar. And the interaction between them, or the net force of interaction between them, is going to be the dipole interaction, refers to polar molecular crystals. Particles are neutral polar molecules, and then the bond between them is going to be the dipole interaction. Then it is considered to be the polar molecular crystals. The example that I have chosen is going to be the solid hydrogen chloride, or I can choose solid sulfur dioxide. Okay. And then the third one is what? Hydrogen bonded molecular crystals. What hydrogen bonded molecular crystals are? Again they are the polar molecular crystals, or they are the crystalline solids in which the Particles are of the neutral molecules, and those neutral molecules are again found to be what in nature? The polar molecule are in nature. But the bond between them is found to be the what? Strong hydrogen bonding. Okay, so due to that strong hydrogen bonding, what happens? The polar molecules gets accumulated to form a solid, and that particular solid is called as hydrogen bonded molecular crystals. The very familiar example that I have chosen for the hydrogen bonded molecular crystals is what? Ice. Okay, in ice the H2O is a polar molecule, and the interaction between the various H2O molecules is by intermolecular hydrogen bonding. That is why it is an example for as hydrogen bonded molecular crystals. Okay, so that is about the first. We have chosen that in the form of which one? The molecular crystals. Okay, so now what is that second here? Ionic crystals. What are ionic crystals here? They are also the, which one? Crystalline solids are the crystals in which the particles are, which one? Oppositely charged ions. Means if one is cation, another must be what? Anion. Which are held together by a which bond? Ionic bond. If that be the case, it is called as what? Ionic bond. Sorry, ionic crystals, or sometimes it may be also referred as electrovalent crystals. So let us take an example. Assume that this is Na plus, therefore this is Cl minus. This is Na plus, Cl minus. Na plus, Cl minus. Na plus, Cl minus. So here what are the particles in this particular network? Just I am reading only the small bit of that. We are usually calling that as unit cell. I will explain that in the later. Okay. So here the particles are Na plus and Cl minus. What Na plus and Cl minus are? They are considered to be the oppositely charged ions. What ions they are? They are the oppositely charged ions. And what is the interactive force existing between this Na plus and Cl minus? How Na plus is obtained? By the loss of electrons. How Cl minus is obtained? Gaining of electrons. Means there is a complete transfer of electrons from the sodium atom to the chlorine atom to get a sodium cation and then the chloride anion, and that electrostatic force between them is going to be the what in nature? Ionic in nature. Means the bond between Na plus and Cl minus is going to be the ionic, and the particles are of oppositely charged ions. That is why sodium chloride is an example for a which one? Ionic crystals, are sometimes it can also be referred as a which one? Electrovalent crystals. Okay. So let us have the structure related to this. So this is the rough model with respect to which one? The sodium chloride structure. Okay. So here observe this red refers to the, for example, Na plus, and this black refers to which one? The Cl minus. Na plus, Cl minus, Na plus, Cl minus, Na plus, Cl minus, Na plus, Cl minus, and so on. So what that shows here? The particles are what? This is the total structure with respect to the which one? The sodium chloride. Here the particles are individually what in nature? They are the oppositely charged ions like Na plus and Cl minus, and the bond between them is found to be the what in nature? Ionic. Means are electrovalent in nature. That is why the name of that particular crystals is considered to be the ionic crystals, or it is also called as electrovalent crystals. Means what the particles are here? They are the oppositely charged ions. Okay. So let's have the next one. The third one is the covalent, or it is also called as the network solids. So here what the particles are? The particles are of which one? Either we can have the two chance. What are those? Either it may be in the form of atomic in nature, or sometimes it may be the molecular in nature. Okay. So that is, either we can choose that in the form of an atoms, or it may be the molecules, but they are held by not the van der Waals force or the hydrogen bond, but they are held by strong covalent bond. Okay. So let us have So this is the structure related to the which one? Graphite, which is one of the allotrope with respect to which one? The carbon. Okay, this is a rough structure with respect to which one? The graphite. Here, what this is? Carbon. What carbon is? A neutral atom. And we know that carbon exhibits the well-known physical property that is called as the catenation. Means the self-linking between the two carbon atoms in forming a very long carbon chain, or it may be the branched carbon chain, or it may be sometimes the cyclic carbon chain, that refers to the which property called as catenation. So here each carbon atom is surrounded by 3 other carbon atoms, such that they are arranged in different layers called as hexagonal layers, and individually those hexagonal layers are held by the weak van der Waals interactions. That is why the carbon is found to be the sp2 hybridized in case of the graphite, and that is exhibiting the slippery property, and that slippery property is due to the which one? The removal of the what layers? The weak van der Waals layers are the forces between the hexagonal layers. That makes the graphite is found to be the very, very soft. And also, as if we know that it is a good conductor of electricity, because the carbon is satisfied with that valency of only the 3 here. Means one electron is delocalizing over all the hexagonal layers, and that free electron helps for the conduction of the which one? Graphite. Okay, means graphite is the best example related to the which one? The covalent crystals, or it is also called as network, because the covalent bond once formed, it doesn't get stagnant as it is, it gets extended to various number of which one? Carbon atoms to form a 3-dimensional arrangement, and that 3-dimensional arrangement also refers to the network. That is what is called as the network solids. I can take the same diamond also. Again, it is allotropic form of this one. Each carbon atom is tetrahedrally surrounded by 4 other carbon atoms. As if there is no free electrons in there, that one it is a non-conductor of which one? Electricity. But due to the total internal reflection, it exhibits the shining surface. It is having the highest shining nature. Okay, means the particles are again the neutral atoms, or the carbon atoms, which are held by the strong covalent bond, and they are elongated, or it has been expanded to a 3 dimension. That is why they can also be called as the network solids. Carborundum, for example, here the particles are silicon carbide. Silicon carbide. Similarly, silicates, sodium silicate, or it may be the potassium silicate, whatever it may be, or magnesium silicate also. So here SiO3 2 minus. So here the particles are considered to be the molecules, and they are held by the same strong covalent nature. Means either we can choose the neutral atoms, or it may be the sometimes which one? The molecules. But the bond between them is found to be the covalent bonds. That is why they are called as covalent crystals, or sometimes it can also be called as the network solids. Okay, so that is about the third one, called as the covalent or network solids. Okay, so let's have the fourth one, that is called as metallic crystals. What metallic crystals are? They are also the crystalline solids, wherein the particles are of which one? The metal cations of the metal. What is that? Metal cations of the metal. They are also called as simply the kernels. And those kernels are held together with respect to the electron cloud through the which bonding? Metallic bonding. That is why it is called as what? The metallic crystals. So let us take an example. So here, let us have M here. What M is? Any metal. Maybe sodium or magnesium or iron, whatever it may be, copper or anything. Okay, anything. So this is called as, if I arrange that in the 3 dimensional, it is called as a metallic crystal lattice. What's that? It is a 3-dimensional arrangement of various particles is considered to be the of metal atoms is called as metallic crystal lattice. That is called as MCl. Okay. Now, Usually what metals are? They are found to be the electropositive in nature. They are found to be the electropositive. Means they can readily lose the what? Outermost electron because of low ionization enthalpy. Usually the metals will have the low ionization enthalpy. They readily lose the what? That is why they are converted to M plus by the loss of electron. M plus, I will write all first M plus. If it is bivalent, they can lose the 2 electrons. If it is trivalent, they can lose the 3 electrons. So here, M plus is fixed. Means it is rigid also. It doesn't change its position, it is always fixed. But the electron lost by that particular atom is found to be the freely moving. And this is called as a sea of electrons. It is also called as electron cloud also. Electron cloud also. So here, as the metal readily loses its valence electrons, means the electrons are freely moving in the whole of the which lattice? Metallic crystal lattice with the fixed position of which one? M plus. Okay. Now, what is the interaction between the M plus and then the M plus? Indirectly, first we will mention that in the form of it is a net repulsion actually we are calling. It is not the attraction, repulsion here. It is an attraction. How that attract here? As if it is rich with electron cloud means this M plus will have an attraction towards the electron cloud in this MCl. Similarly, the same M plus is having an attraction with respect to the electron cloud in this MCl such that the 2 M plus gets attracted, and that bonding is called as which bonding? Metallic bonding. That bonding is called as metallic bonding. So here, between the 2 metal atoms, there is a formation of a metallic bond. Through the help of metal cations of the metal, they are called as kernels. Here M plus are called as which one? Kernels. All the nearly 75 or 76 elements of the periodic table are considered to be the which one? Metals. Means the molecular, it is the crystalline solids in which the particles are which one? Kernels. Simply we are calling that as kernels. What kernels are? They are the metal cations of the metal. Metal cations of the metal means they contains only the innermost electrons but not the outermost, because the outermost electrons are freely moving and they form a sea of electrons, or it is also called as electron cloud. In that sea of electrons, the kernels has been inserted with a fixed position, and between the 2 kernels there is a net interactive force, and that interactive force is called as a which bonding? Metallic bonding, and that makes the crystal, and those type of crystals are considered to be the which one? Metallic crystals. Okay. So this is about the classification of which one? The crystalline solids, are simply it is also called as which one? The crystals. So here the crystalline solids, we know that there is a regular arrangement of the particles. The solids in which the particles are regularly arranged means they are considered to be the crystalline solids. And those crystalline solids has been classified under 4 different categories based on the type of particles that has been present, or the nature of the particles that has been present, and also what type of interactions that can exist between them. So based on that we can have the 4 different types of crystals called as molecular crystals, ionic crystals, covalent crystals, and then the metallic crystals. If the particles are the neutral molecules which are held by either the weak van der Waals forces or it may be the strong hydrogen bonding, then it is called as molecular crystals. If the particles are of which one? The oppositely charged ions which are held together by the strong ionic bond, then it is called as ionic crystals, or sometimes it is also called as electrovalent crystals. If the particles are sometimes the neutral atoms, or some cases it may be the molecules also, but the force between them is found to be the strong covalent nature, then that refers to the covalent crystals, as it gets an expanded structure. That is why it is also called as the network solids. And finally, the same crystalline solids in which the particles are the kernels. What kernels are? They are the metal cations of the metal. Metal cations of the metal that has been immersed in the sea of electrons, or it is also called as mobile electrons or electron cloud, through the which bonding? Metallic bonding means it is called as what crystals? The metallic crystals. Again, we have classified the molecular crystals under three different categories called as non-polar molecular crystals, polar molecular crystals, and then the hydrogen bonded molecular crystals. The same neutral molecules, particles are neutral molecules, strictly they are the non-polar molecules. And the bond between them is found to be the London forces, or it is also called dispersion forces, or sometimes it can also be mentioned as the induced dipole interaction, means it is called as non-polar molecular crystals. If the particles are the neutral polar molecules, particles are what? Neutral polar molecules, which are held together by which one? Which are held together by what? The covalent bond. Sorry, not the covalent bond, which are held together by dipole interaction. Sorry, which are held the polar molecules which are held together by the polar covalent bond, or indirectly we are calling that as the dipole interactions. After that covalence, we will have next one, that is the polar molecules which are held together by which one? The dipole interaction. Then it is an example for a polar molecular crystals. And lastly, if the particles are the polar molecules again, the particles are again the what? Polar molecules, but they are held by which bonding? A strong intermolecular hydrogen bonding. Then it refers to the hydrogen bonded molecular crystals. Best example that we have chosen with respect to the hydrogen bonded molecular crystals is the structure of which one? Ice. Okay, so this is about the what? The various types with respect to the crystalline solids. It is based on what is the nature of the particles that has been present and what type of interactions or the bonding that has been existing between those particles. Okay, in the next we will move on to the what are the various characteristics with respect to this structure of the crystals. How the structure of crystals has been studied by X-ray analysis. Means if any solid powder is there, if I flash a light of X-ray on that one and expose to the photographic plate and observe that, we are calling that as X-ray analysis. That X-ray analysis shows that we are having the 6 parameters in which 3 are the edge lengths and 3 are the axial angles. Based on the type of the edge lengths and then the axial angles, we are having the various terms in the form of lattice point, unit cell, crystal lattice, and then the coordination number. So these are various terms that has been related to the structure of strictly the which one? Crystalline solids. Because we can't concentrate on the structure of the amorphous. Why? Because amorphous means there is no regular arrangement of its particles. Means we can't expect the definite shape of that one. That is why we are concentrating much only on the structure related to the crystalline solids. Okay, so that structure of crystalline solids are the crystals that we will discuss in the third session of this particular solid state. Okay, so thank you.